Hi, good afternoon, morning, evening, wherever you are. We've been instructed on a new insurance claim. This is a fire in a couple of properties. Day one visit. I say day one, it's actually day two because we visited a while ago, measured up one of the properties. They're all identical, kind of what we call handed. So one's on the left hand, one's on the right hand, right hand, and work way through the block like that. But we were prevented high level access because scaffold wasn't complete. So the scaffolding now is, and we can get to look at the properties and see the damage. Still can't get inside them just yet because there's a mix up with keys. But I'll just show you what we're looking at. For any students watching, these houses are cross-wall construction. So we have load-bearing party walls, and then everything on the front and rear elevation is non-load bearing, and steel beams are popped in to support the roof. So I'll show you those details as well. So we'll have a wander about. What we've got to deal with, unfortunately, is the scaffolding is in the way everywhere we go. But hey, that's life. At least we've got safe access around the property, which is the absolute critical thing. You might hear the Monoflex sheeting flapping away in the background. Again, completely normal. So here on one of the houses, we can see the the gable wall, and then we've got a party wall between the two properties. Cavity brickwork, so face brickwork outside on the balconies, and block work inside on the actual party walls. We've then got this steel beam that runs right the way through the properties, and actually if I go back to the end of the house, you can see how steel performs sometimes in a fire, because what we can see here is the deflection that's occurred. Just about see it in that steel beam, and over there maybe on the joint between the two you can see that's a bit more evident. So it's all in a bit of a sorry state, but we will get this repaired. Total of 6 houses were involved in this fire. 6 houses were affected by the fire, should I say. What we've got, which is a little bit interesting, don't see it all that often other than the cross-wall construction, we've got what we call an internal dormer. So where the roof here spans from the ridge with traditional roof space and then down to our eaves at low level, we've then got this internal dormer arrangement, which is not quite the same height as the floor joist for the main building. It's stepped up somewhat, so that internal sill level might be at around 1100 millimeters. So we need to do lots of detail, as well as our general arrangement plans. We need to detail up exactly how all these are going to be supported, reconstructed, weathered in and finished. Times 6, because there's 6 houses involved in the fire. So just a little bit of an update, not a particularly long video, but we've got to start the process of now going through and working out. We'll do it as a phased job. So first of all, we our general arrangement plans done as we've got at the moment, what we call as existing or as built. We'll then do a series of strip out drawings, which is everything that needs to come out and be taken away, and that will leave us with what's left. Now, just as an example, obviously we're going to take away the remainder of the roof, and we're going to take away the steels because they've all deflected. But we've then got our timber frame walls to the front and rear of the property that they will need to come out at first floor level as well. And if you can hear it, not sure you can, but just over there, there's a mains water has been left on in one of the properties, and that's still leaking. So that's going to be causing a lot of damage until we can actually get access inside the house to get that switched off. So once we've got our strip out drawings done, we can then work out our detailed proposals of everything that needs to go back. So that's the roof structure, the fire protection between the party walls, our flat roof details, our replacement joist details, everything through to finishes, door schedules. We'll then put together that in a schedule of work, which will detail what needs to be done in each house. And we'll also include something we call NBS, which is the National Building Specification for the internal and external finishes. So the difference between a schedule of work, for example, and an NBS is if we take these tiles, for example, our drawings will show these single lap tiles that need to be replaced. Now, our schedule will say, supply and fix, replacement, double Roman, whatever tiles. But our NBS schedule will actually say how they're going to be fixed, at what intervals, what the headlamp will be, and everything like that. So it's a lot of detail that goes into a separate document. We can just about see here that these are Marley, so that gives us an indication that we'll be able to go through Marley's website, find out what those tile types are, so that we can get those re-specified to go in exactly the same. So no doubt there'll be further updates on this job. I hope you do like our videos. We've been getting quite a few comments. For the size of our channel, we've been getting quite a few comments. Saying that people are liking what we're doing. It is an interesting job. So if you do like what we do, please like and subscribe. And if you've got any questions, let us know and we'll answer them in a video or in one of the comments. Thank you very much. Okay, so I'm going to carry on with our inspection. Apologies if the sound is not great. We are under a monoflex sheet. So here we have, so it's a cross-wall construction. So load-bearing party wall, nothing inside the property is load-bearing, but the roof needs supporting. So these are actually onto these steel beams. They're about 250 by 140 or so and run through here. To the top of the stills, we've got our wall plate, very odd size, 130 by 38. And then our trusses are fixed to the top of the wall plate, and you can just about make out in there, there's a truss clip. We then got, there was an underlay at some point, and then we've got our battens and our tiles. So what we do to make sure we're getting the right details for putting it back, the whole thing is measured up straight onto the iPad, and then just take a photo of that, pop it into the iPad as to what we're doing. So here we've got our steel 250 by 140. We've got 165 from the outer edge of the steel to the outer edge of the fascia, and the fascia board is actually 380, so quite a beefy fascia. But this all helps putting it back together. So we'll have it around the back of the property now. So our inspection of the rear of the property, we're looking to work out how everything's been constructed and put together. So we've got a good view here of the cavity wall. There's an undercloak here, possibly asbestos cement, we don't know that just yet, but given the age of the property, it's built in the 80s, more than likely so. If we slide that out of the way, we've got now a very clear view of the cavity wall, and we can see that there's blown fibre insulation in the cavity which needs to be removed because it's full of rubbish and debris from the fire. Our overall thickness here is around 260, 100mm block, 60mm cavity and 100mm facing brickwork. So we've got our eaves detail at low level that we've been able to just confirm, slightly different than the front, because at the front our roof pitches onto the main steel beam, but the back here we've got some lateral ceiling joist stroke flat roof joists, but then the flat roof appears to be supported separately on these 150mm timbers that go the other way. So one of the little issues we've got is when we need to put this flat roof back, we don't have sufficient upstand for insulation nor any ventilation means. So we've got to take these joists out. So we'll probably put these back sufficient to span from party wall to party wall, and then our 150mm we're going to lose by not having floor joists can be made up with insulation. So all this information is recorded onto our iPads, and here we've got our different, can't see it because of the roof, we've got our different dimensions, where our stud partition is, where the external wall is, which is actually 100% window, and then our cavity dimensions, how that middle wall is made up, what our floor joist sizes are, what our cavity sizes are, and again, because this wall is set back slightly from the fascia, we've got measurements of the different walls. Sometimes we will take a photo and add all those dimensions to the photo so it's quite clear what we're measuring up. Now there's quite a step in the building as well, so we've just measured up the gable wall. We did it originally from ground floor level, but here we can see from the quirky little rebated bit, which is 415 high, there's an overall 1400mm from that point on the front elevation to that same point on the rear elevation, so 1.4 meters difference. This is the kind of stuff we're looking at when we're doing a fire damage inspection. So I hope you found this interesting. Thank you for watching.